Ancient monuments of Rome. The Colosseum was a vast amphitheater where various spectacles were presented. This gigantic structure had a capacity of 50,000 spectators. It is a symbol of the splendor of ancient Rome and of Christian martyrdom. The Colosseum was constructed by Vespasian and Titus around 80 AD. Gladiatorial combats and simulated naval conflicts were presented for the Roman public. During the medieval period, this famous structure was used as a quarry of materials for new constructions. The forums of Imperial Rome are located along Via dei Fori Imperiali. The Roman Forum is located in a zone of the capital that was once the political and commercial center of the world. The Curia, in which the Roman Senate assembled, is situated in this forum. The best preserved monuments are the Arch of Septimius Severus, the Arch of Titus, constructed to commemorate the victories of Vespasian and Titus over the Jews, and the Basilica of Maxentius, where today, during summer seasons, it is possible to go to orchestral concerts. Ruins representing many other important ancient constructions, the tomb of Romulus, Basilica Aemilia, the Temple of Saturn, Basilica Julia, the Temple of Julius Caesar, etc., clearly recall the half-legendary and half-historical origins of Rome. Another noble monument of classical antiquity, the Pantheon, was constructed by Emperor Agrippa in 27 BC. Even though this monument was plundered several times, it is the best preserved construction of ancient Rome. Its dome is one of the most interesting architectural constructions in history. The tombs of the artist Raphael and of some sovereigns of Italy are in the Pantheon. During the imperial period, the Palatine Hill was the aristocratic area of the city. The House of Livia is a testimonial of the splendid style of residences of that period. The Circus Maximus is also located in these vicinities. Its great arena had a capacity of at least 300,000 spectators. The Capitoline Museum is located near Piazza Venezia, behind the gigantic Victor Emmanuel monument. Various famous sculptures are exhibited in this museum. The collections of this museum, along with those of the Vatican, constitute the most important source for the study of ancient art. The Arch of Constantine is located beside the Colosseum and is one of the most familiar and most photographed monuments of ancient Rome. The great Roman conquerors marched through this arch to celebrate their military victories. The sculptured figures on this arch were copied from other monuments. Castel Sant'Angelo was originally constructed by Hadrian and was used as a tomb for all the emperors until Septimius Severus. Later, this massive construction became a fort used by the Vatican for its defense during the medieval period. In 1870, it became the property of the Italian state. Today, it is an artistic and military museum containing a unique collection of weapons. Many other ancient monuments may be found on the Appian Way. Rome, possessing very many other interesting attractions, fountains, churches, typical squares, palaces, towers, bridges, catacombs, museums and galleries, is continuously visited by tourists from every part of the world.
Evolution. Commonly, the term evolution indicates any sort of progress or development. When someone says, for example, that modern industry has evolved, this means that primitive and inefficient techniques have been overcome. Scientists frequently use this term in a generic way to describe the evolution of climates, of continents, of the solar system, and of other dynamic phenomena. In most cases, however, scientists, biologists in particular, use it in reference to the theory of organic evolution that dates back to 1859, when Charles Darwin published the work that made him famous, The Origin of Species. In his youth, 1831, Darwin was engaged as a naturalist on an English government vessel and travelled around the world. In this voyage, he could therefore observe the biological and geological nature of the New World, America, and of remote, uninhabited oceanic islands. He was particularly interested in the biological mutations of animal life existing in various continents. Returning to England in 1836, Darwin commenced a study to explain the enormous differences discovered among animal species throughout geological times. Some writers of the 18th century noted that every animal species somehow struggled for its survival. The mechanism of reproduction and elimination of living organisms maintained a certain equilibrium in nature. Nobody, until Darwin, realized that a continuous mutation within every animal species was necessary to maintain this equilibrium. It was an illusion of men to believe a certain stability in nature, but this belief was gradually eliminated by the paleontological discoveries and by the principle announced by Darwin of natural selection. In his famous work, Origin of Species, he affirmed that the mutations in the animal and plant world were due to the tendency for each organism to change in a certain limit and in a certain direction its hereditary characters in consequence of their environmental conditions. As soon as Darwin presented his theories and opinions, they created enormous controversies. He could not scientifically explain how the variations among organisms occurred. However, within 10 years from the publication of his book, the theory of evolution was accepted by professional biologists, even though the details of the actual process were still a doubt to resolve. Darwin's contribution was fundamental in creating the basic principles of modern biological sciences. Modern genetics, which is a branch of biology, has finally scientifically explained the mechanism of evolution discovered by Darwin.
Biochemistry. Biochemistry is the study of the chemical composition of substances that constitute living entities. It combines the study and techniques of biology with those of chemistry. This science is particularly concerned with the chemical processes which take place in plant and animal organisms. Used in a more restricted sense, the term biochemistry is the study of the chemical nature and processes of human organisms. Biochemists have obtained through their activities a lot of benefits for the human race. For example, they have discovered fundamental elements concerning nutrition. They have aided doctors in the conquest of maladies by creating drugs which kill or inactivate harmful bacteria, and they have discovered useful facts about the functioning of glands and their effects on the growth and activity of the organism. The cells of plants and animals contain thousands of different chemical compounds. A lot of these compounds are familiar to chemists. Some of them can be synthesized in laboratory. The structure of others still remains a mystery. The principal compounds of plant and animal organisms are carbohydrates, fats, and proteins. A lot of other chemical substances can be identified in living tissues. Infinitesimal traces of minerals are essential for the continuance of life. Bone structure, for example, is substantially constituted by the mineral calcium. Living cells also contain acids and alkaloids. The study of respiration in plants and animals consists in observing how certain gases are transported in their bodies. In human beings, for example, blood extracts oxygen from the pulmonary tissues and distributes it throughout the body. Animals discharge carbon dioxide into the air, while plants utilize it and discharge oxygen. Plants create their chemical reactions through a process called photosynthesis, for which the presence of the chemical substance known by the term chlorophyll is essential. A group of scientists at the University of California, directed by Daniel I. Aaron, first succeeded in creating photosynthesis outside living cells in 1955. These scientists isolated chloroplasts, chlorophyll-containing units, from spinach leaves and induced them to continue photosynthesis outside the leaves. This scientific progress opens up the possibility to produce food by artificial photosynthesis in future. Biochemistry continually augments our knowledge of the chemicals necessary for plant and animal survival. Humans and animals must ingest foods containing chemical substances called vitamins in order to maintain normal body functions and life itself. Enzymes promote and direct chemical reactions in all living organisms. They decompose ingested nutriments into particles suitable for absorption and utilization by the body. Without such minerals as iron and copper, human blood cannot function effectively. Hormones regulate the rapidity of growth and consumption of food and energy in both plants and animals. Other processes studied by biochemistry are fermentation, necessary in preparing bread and manufacturing alcoholic beverages, and decay, for example dental decay, which derives from the destructive action on living tissues by bacteria. Both are chemical processes deriving from the action of microorganisms.
A visit to Greece and its magnificent islands. Legendary Greece, located in the Mediterranean Sea, is the ideal for every person who seriously wants to consider an adventurous, unusual vacation. It is possible to go to Greece by aeroplane, ordinary means of transport, automobiles and buses, train, or by sea. The most fascinating experience consists in exploring the numerous, tranquil islands situated in its vicinity. There are various commercial organizations that rent and sell the most sophisticated motor yachts. They offer the most complete guarantees on the characteristics of every model: motor power, cabin space, quality of materials used in construction, etc. Usually, these organizations also prepare and suggest touristic itineraries. They provide maps, pamphlets, nautical charts containing details of the routes, topographic plans of ports, and meteorological data. There are illustrated descriptions of every island, a brief relation on their history, and an interesting description of their natural characteristics. The actual distance between the islands is minimal. Frequently, it is a question of traveling 1 or 2 hours, so that an expedition on all the islands is not only exciting but possible. Some of these islands are still in their natural state. On Delos, there are antique ruins, the remains of magnificent cities, fragments of civilizations, and fragile relics. Monumental columns, mysteriously intact, support massive rock constructions. Abandoned amphitheaters create an unreal atmosphere. The sole indications of life on this island, but also on many others, are given by the presence of some domestic animals which graze on green plains. On Ios, the situation is practically identical. However, there is a notable concentration of habitations near the port. A great problem here is constituted by the scarcity of potable water. This is the reason for the grouping around the port of inhabitants and their homes. It frequently occurs that a lot of persons receive photographs by post from their acquaintances who are visiting famous locations in Greece. These photographs confirm that Greece really is as it is described: candid cities, exotic churches with conical domes, and elegant, uniform constructions. As an alternative to the fabulous natural sceneries offered by the isolated, uninhabited islands, on other more populated and larger ones, there are a myriad of restaurants and hotels, boutiques and shops that offer every type of object. A precious art, antique in design and form, marvelously decorates the interiors and exteriors of edifices. On Mykonos, Seriphos and Siphos, tourism has invaded and completely altered the original social characteristics. The islands have become commercial centres and offer all tourism services. Tourist guides and local tariffs are competitive. Second-class pensions and hotels are usually situated along the ports. Real Greek culture and traditions are slowly disappearing on these famous islands. What remains is the fascinating Greek climate, lethargic and hospitable, and the good, strong coffee. The antique, heroic Greek civilization has been replaced by a modern society and a lucrative tourist industry.
Distillation. Distillation is a process in which liquid solutions are boiled to produce gas or vapor that is subsequently condensated. This process is used to separate the components of liquid mixtures. We know that liquids exposed to air slowly evaporate. This means that a liquid slowly transforms into an invisible gas called vapor. With heat, this transformation may be accelerated. If the temperature of the gas falls, liquid forms again. This reverse process is termed condensation. The process of condensation may be accelerated by the use of refrigerating techniques. An example of the two phases of the distillation process in nature is the continuous evaporation of water that forms clouds and the condensation of clouds from which rain is derived. The instrument used for distillation is called a still. This instrument is composed of three parts. The first part is a container in which the liquid to be distilled can be heated. The second part of the distillation instrument is the condenser. In this part, the vapor obtained during the heating process condenses and becomes a liquid again. The third part is called the retort, which is a container in which the distilled liquid, termed a distillate, is collected. A lot of liquids are purified by the process of distillation. In fact, when a mixture of solids and liquids, such as seawater for example, is heated, the liquid evaporates, leaving behind the solid residues. If the mineral part is the desired product, the process is reduced to the sole liquid evaporation. Fractional distillation is used when several liquids are contained in a solution. As generally diverse liquids have diverse boiling points, a fractional distillation is possible. Let's make a practical example. Let's suppose we have a solution composed of alcohol and water. We know that alcohol boils at 78 degrees centigrade and water at 100 degrees centigrade. A thermometer must be added to our basic distilling instrument. Observing the thermometer, we will separately collect alcohol, heating the solution to 78 degrees centigrade, and then distilled water at 100 degrees centigrade. In this process, each distillate is usually redistilled in order to obtain a purer distillate. Fractional distillation is a very important industrial process. It is used to produce distilled liquors, and it is essential in petroleum refineries. Petroleum in the natural state is a combination of various substances that must be separated in order to be used. Benzene, naphtha, kerosene and oil, having different boiling points, all result from the fractional distillation of petroleum. Simple distillation and fractional distillation do not produce new substances. They merely separate combined substances. The process of destructive distillation, involving the decomposition of natural substances, can produce new substances. This form of distillation is a chemical process, and an example of it is the transformation of coal into coke.
Tea. Tea, the infusion prepared from the leaves of the Thea sinensis plant, is the most popular beverage. It may be considered the national beverage of England, China, Japan and Russia. In England, for example, afternoon tea, generally served with biscuits or pastries, is a tradition. England imports more tea than any other nation. The average Englishman's tea consumption equals that of 15 Americans. The tea industry is above all developed in India, Ceylon, Indonesia and China. According to an Oriental legend about the origin of tea, it is told that once a saint in India remained in meditation and prayer without ever stopping for a lot of years. Finally, one day he fell asleep. When the saint awoke, he invented a system to prevent the recurrence of this disadvantageous fact, and continued his prayers for 5 more years without sleeping. Eventually, he was incredibly exhausted. He then masticated the foliage of a plant that was in his vicinity, and suddenly felt awake and energetic. He spoke with various persons of the miraculous powers of this plant, and many of them gradually commenced to use it. Another interesting story concerning the discovery of tea goes back to 4,500 years ago. While a little water was boiling for the Chinese Emperor Shi Nung, a few leaves accidentally fell in it. Because the orange-colored water emanated a delicate aroma, the emperor drank it. He liked it so much that he included it in his daily diet. As this beverage also cured his dysentery, an intestinal malady common in ancient China, he convinced himself that tea was a miraculous medicine. Instead, we now know that the cure only consisted in boiling the contaminated water. Only in the 17th century, merchants from Holland imported tea from China and diffused it throughout Europe. The English adopted it enthusiastically. It was so popular among the English colonists of North America that when Parliament imposed a tax on tea, they rebelled. In Boston, a few colonists in Indian costume threw tea into the ocean, the Boston Tea Party. And this fact was one of the elements that provoked the American Revolution. Tea may be consumed hot or iced. The English prefer it hot with sugar and milk added, whereas the Indians add to it a mixture of spices. The Russians occasionally substitute sugar with marmalades. The French dip a sweet cake termed madeleine into tea. The consumption of tea in moderate quantities is innocuous for adults, but like coffee, inadvisable for children. Tea contains caffeine, a drug that increases blood pressure and acts as a mild stimulant. Large quantities of caffeine produce undesirable effects on the nervous system. Tannin, also present in tea, is slightly toxic. Savory and fragrant infusions of herbs, such as mint and chamomile, may be substituted for tea. Wild Thea sinensis can reach a considerable height, but the cultivated plant is constantly pruned to create a small bush with many branches and abundant foliage. It needs a hot climate with abundant precipitations. When it is 3 years old, the plant commences to produce sufficient foliage for profitable harvesting. Prime quality tea derives from the young, tender leaves.
Biography. A person's biography is the story of his life. If the author labors conscientiously in the research of all particulars, the result will be a marvelous work. The author of a biography must spend a lot of hours in research, collecting and selecting interesting material. He may commence by consulting general reference books such as, for example, encyclopedias and various history volumes to study better the epoch in which the subject of the biography lived. Letters, diaries, films and photographs are very useful and help the author to understand his character's personality and private life. If this character is still living, the biographer will certainly meet him and request an interview. If he is fortunate enough, he may obtain several meetings in which important episodes can be clarified. If the subject is dead, the biographer will visit the places where the subject lived and worked, holding conversations with acquaintances and relatives in order to collect their impressions and opinions. The subject's family or his acquaintances may have documents that mention him. The biographer has to put together many elements in the process of interpretation and composition of the facts. After all, this is not so simple, as different persons may state different reports. This difficulty is often increased by time or by the distance of locations where the subject had lived, and facts may result obscured by rumors and legends. Often, as in the case of the American author Edgar Allan Poe, the only contemporary testimony available is prejudiced and hostile. The author of a biography must be careful not to accentuate certain facts too much and not to eliminate others, whether he wants to create a more interesting, coherent story or to defend or condemn his subject. The biographer must be an artist conscious of the reality that he wants to describe, using all his ability. He must act with conscience and intellect, and his style must be clear in order to reach a popular consent. The first biographer was a Greek named Plutarch, who lived in the 1st century A.D. His work, Parallel Lives of the Greeks and Romans, included biographies of numerous ancient figures, politicians, artists, and heroes, men of action who had important positions in their communities. Plutarch concerned himself more with his subjects' role and influence in society than with their personalities. He wrote the story of these heroes to give an example for all human beings to imitate. His biographies are still read for the information they contain about ancient personalities and events, as well as for their clear, concise style. During the Renaissance, when the dignity of the individual was recognized as being of primary importance, biographers became interested in their subjects as individuals and not only as examples to imitate. Writers such as Giorgio Vasari attempted to utilize facts to interpret their subjects' personalities and explain their importance. His work, Lives of the Painters, published in 1550, is still read for the information it contains concerning artists such as Giotto, Leonardo da Vinci, and Michelangelo. It is James Boswell, however, who has the honor of being considered the first modern biographer. He collected every possible element concerning Samuel Johnson's life, following him everywhere, recording his conversations and actions. His work, Life of Samuel Johnson, published in 1791, presents all the elements collected by the author in an accurate and lively form. His work is still read today for amusement, for historical interest, and as a model for biographers.
Archaeology. Archaeology is the study of ancient monuments, languages, religions, institutions, and customs in order to augment our culture on previous civilizations. Archaeologists investigate the past as if they were detectives investigating a mystery. They are interested in discovering how those persons whose objects and habitations have been found lived. Archaeologists occasionally discover rare and precious articles, such as, for example, an Egyptian sarcophagus. But the discovery of fossilized animal skeletons, for example, may have a greater importance in determining the existence of a prehistoric civilization. In their researches, archaeologists need the cooperation of various scientists. Archaeology is a group activity. Geologists are concerned with the physical structure of the earth. Zoologists identify animal remains. Petrologists and mineralogists study minerals. Chemists and physicists investigate on the material composition of objects that have been discovered, on their age, and using particular methods, maintain them in good state. Archaeology is usually considered a branch of anthropology. Anthropology is the study of man as a biological organism. Anthropologists identify the racial groups in which man has evolved, examining characteristic parts of their skeletons. Cultural or social anthropology is the study of the religious customs, social organizations, and other traditions of prehistoric communities. Archaeological zones are difficult to localize. They are usually below the surface of the earth and are discovered through natural causes, such as, for example, erosion, or through methodical researches. Occasionally, men engaged in activities such as construction of edifices or mineral excavations may discover important zones of archaeological interest. Archaeologists also study ancient literature to discover locations of archaeological importance. Religious documents, such as the Bible, for example, are also very useful. The legends and epic poems of Homer led the German archaeologist Heinrich Schliemann to Troy. More frequently, the archaeologist uses sophisticated scientific and technical methods of research. An important technique is aerial photography. Photographs taken from aeroplanes or helicopters reveal interesting geological characteristics. After having accurately localized an archaeological zone, archaeologists can locate exactly, without digging, the position of objects that are under the surface of the earth with a resistivity examination. Such an examination is effectuated by passing an electric current through the ground in order to measure its electrical resistance, which is determined by its humidity and saturation content. The materials that ancient objects and monuments are composed of contain small quantities of water and therefore increase electrical resistance in their immediate vicinity. A lot of other technological procedures help modern scientists in their research of antiquities.
Music. The history of music is as ancient as the human race. Music was first expressed by the percussion of hands and feet, and particularly by the melody of the human voice. Rhythm, a regular beat, was of fundamental importance for chanting, dancing, and marching. Music constituted a non-verbal system of communication, attributing specific significance to various rhythms. It has been utilized to express or re-evoke emotions, to incite groups of people to action, to accompany strenuous or dangerous activities, to celebrate good fortune, and to relax. Music was so important to antique civilizations as to be considered a celestial gift, a manifestation of divinity. The Egyptians, Greeks, Chinese, Hebrews, and Indians believed that music drew its origins from paradise. The patron divinities of music from whom the term is derived were the Muses, who governed the arts and all harmony in the universe according to Greek mythology. Noise has various elements in common with music, but the difference that distinguishes them is very simple. Noise is the result of sounds created without a system, without rules. The rules according to which music is composed form a harmonic system which may be mathematically analyzed. These rules are melody, tone, harmony, and rhythm. A note or chord are a part of music, a musical sound, but music is, in its entirety, a series of programmed sounds. Music may be classified in various branches, such as, for example, vocal and instrumental music. Oratorios, operas, and lyrics are traditional forms of vocal music. Instrumental music comprehends symphonies, concertos, and solos for specific instruments. Other categories are classical, folk, and popular music. Music may be composed for theater, ballet, cinema, radio, or television. Modern society utilizes music for a lot of functions: educational, social, professional, patriotic, religious, and therapeutic. Studying music contributes to the intellectual and artistic development of the individual. Groups of persons often meet to create or listen to music. Musicians and music instructors, with their ability, can earn money through this profession. Nations use patriotic music to inspire the populace with courage, determination, and unity. Religions communicate spiritual emotions through music. Doctors and psychologists use music to heal some maladies.
Jet propulsion. Jet propulsion is a method used to develop energy that moves airplanes and missiles. This form of propulsion is based upon elementary principles of physics. Jet propulsion techniques have caused a radical revolution in modern aviation technology. Although modern jet-engined aircraft are the result of recent inventions and technological developments, the basic principle of jet propulsion was discovered over 200 years ago. The phenomenon of reaction which provokes the movement of a jet-engined aircraft may be observed in nature. In fact, every action generates a corresponding action in the opposite direction. This principle is the basis of jet propulsion. The English scientist, Sir Isaac Newton, stated this principle in 1687. He considered it as the fundamental law of motion. In his famous scientific study, Principia Mathematica, Newton expressed this principle in the following form: to every action corresponds an equal contrary reaction. In the traditional type of airplanes, combustion produces energy for rotation of a propeller. In jet propulsion systems, combustion produces energy in order to move gases at high velocities. In fact, scientists consider this form of propulsion extremely important for future progress of space travel. Let us analyze the principle of jet propulsion better. A jet motor sucks in air from the front and maintains it inside, determining a great pressure. At a certain pressure, air exits at an extremely high velocity from the rear of the engine. This fact constitutes the action of the motor. This action produces a contrary force called reaction that pushes the motor itself forward. Let us make a simple experiment. A balloon filled with air will represent our jet motor. If we leave the balloon with an open extremity, we will notice two facts. 1. Air will immediately exit from the open extremity of the balloon. Action. 2. The balloon will move in the opposite direction of its open extremity. Reaction. The most familiar type of jet engine is the turbojet. This motor is mounted on most military and commercial airplanes. It is composed of four main sections: the compressor, the combustion chamber, the turbine, and the exhaust. The compressor sucks air into the motor and compresses it. Next, this air enters the combustion chamber, where, combining with fuel, it is ignited. The resulting explosion, constituting the action, creates an enormous pressure in the motor. The expanded gases then rush through the exhaust, creating the reaction or propelling force. As the gas passes from the combustion chamber to the exhaust, it spins a turbine which is connected by a shaft to the compressor. Therefore, the outgoing gas, spinning the turbine, operates the compressor, which sucks in more air, and the cycle starts again. Jet-engined aircraft are superior to propeller aircraft. Vibrations are greatly reduced and velocity increased by use of jet propulsion systems.